I'm Jim Welleman with Muller Engineering Company, and I'll be presenting with Holly Pisa of the Mile High Flood District and Sarah Johnson of Muller on developing and implementing a plan for topsoil. It's here. The Flood District has a topsoil management guidance document on their website. I'm going to be covering why topsoil matters. Holly will cover the layout of the guidance, and then Sarah will wrap up with case examples on how to use the guidance. To understand why topsoil matters, we need to consider a water balance. This is for a 10-year event. Where does precipitation go when it falls on a natural watershed? Precipitation is the purple arrow, and the surface runoff that occurs from that precipitation is the blue arrow. All the green arrows represent processes that absorb precipitation. And why topsoil matters is that for a natural watershed, more precipitation ends up in the soil than it does running off. But if we compare that same event falling on an impervious surface, infiltration goes to 0 and surface runoff increases 7 times more than historic. When we put the two together, pervious and impervious areas in an urban watershed, and we'll just say 50% impervious, surface runoff still increases a lot, 4 times historic. Infiltration is small. But if we, through stormwater management processes, reverse the arrow of the surface runoff and take that impervious runoff onto the green areas, then we can come close to reproducing the kind of hydrology that develops in a natural watershed. And we can increase infiltration markedly. But what's necessary is that we need high infiltration capacity in the green areas of our urban landscape. So we'll be talking about how to accomplish that. And if we do accomplish it, we won't just increase infiltration, we'll produce healthier vegetation that has a number of benefits. Now, high infiltration capacity is possible. This is a chart that shows infiltration actually in my front yard, which is kind of a loamy soil with irrigated turf grass. You can see the infiltration starts at 60 inches an hour and goes down to 20 inches an hour. And that's a high rate compared to what we're used to using for flood control hydrology, shown at the bottom. What we found through some studies and through the literature is that high infiltration capacity comes not just from the soil, like a sandy soil, but it comes from a healthy topsoil and vegetation working together. This is a bar chart that shows a series of infiltration tests, and you can see infiltration rate in inches an hour on the y-axis. And once plant growth starts in these two, in the sample, you can see that the brown bars of infiltration keep decreasing even to 0. And that's because without the vegetation, the soil particles sealed off at the surface. But once that plant growth started in the vegetated sample, infiltration increased. We've proved this out in a number of ways. This is just a simple bucket test where we sprinkle 2 gallons of water on different media. On the left is bioretention media in the chart, and on the right is sod over loam, which is more clay than the bioretention media, which is very sandy. The blue bars represent how much of that 2 gallons runs off, and so for that sandy media, almost 70% ran off. But in the sod over loam, only 30% ran off, a lot more infiltrated. So it's really the soil and the vegetation working together that's the key to high infiltration capacity. So why topsoil matters is because of its relationship to plant health. It helps support plant health. Topsoil does that by providing the nurturing environment for seeds to sprout and grow and provide moisture holding capacity. That's why sand is not good at supporting plant growth. Soil also supplies the plant roots with air and nutrients in addition to the water, and it hosts a community of living organisms to enhance the functions of plants. So healthy topsoil grows healthy vegetation. In turn, healthy vegetation helps build up healthy topsoil. It stabilizes the soil, it creates surface roughness to capture rain and runoff, also keeps those soil particles from sealing off. The vegetation provides pathways for air and water to penetrate into the soil, and also it evacuates pore spaces through its roots and evapotranspiration so that the soil has more capacity to infiltrate in the next storm. Plants add organic matter, and the plants actually live in a symbiotic relationship with those organisms in the soil. Together, they do a lot to protect water quality and protect the land and our streams. So together they increase infiltration like we already have seen. They stabilize the land, so less erosion, and that's really important along stream corridors and floodplains. And then also the vegetation and soil work together to slow down runoff. And through the slowing down of the runoff and the infiltration, it reduces peaks, volumes, and frequency of runoff. The vegetation improves filtering and water quality. The photo on the lower right just shows a little demonstration of putting turbid water, mixing it in with this water that's being poured out on the grass. And just about 10 feet downstream, the water was completely clean, just to demonstrate the filtering effects. Also, healthy soil and healthy vegetation really conserve water by allowing water to penetrate the soil rather than running off, and by holding it there. What is healthy vegetation? For our purposes for stormwater management, we want turf-forming grasses that provide dense coverage over the ground. We want vegetation that's suited to the hydrology of the area, whether that's wetter or drier, suited to the soil conditions. We want that hydraulic roughness to act as a detention basin on the surface, and we want the vegetation relatively free of weeds and invasive species. We really would love good root penetration, which takes native grasses, and this graphic just shows how deep some of the native grasses' roots can go compared to sod, which is way over on the left. What's healthy topsoil? Well, it's not clay and it's not sand. The reason is, even though sand is positive in terms of drainage rate and aeration, it's really poor in terms of water holding capacity, organic content, storage of plant nutrients, and pollutant absorption. And clay is exactly the opposite. Neither one is very suitable. What we want is a loam, and loams are in this area of the USDA soil triangle. Loams are a mix of sand, silt, and clay, and together they score high on all of these important categories. Healthy topsoil is also living. A cup of soil contains all this bacteria, fungi, protozoa, nematodes, arthropods, earthworms. That's really the secret of why soil is important and why it functions so well. This is a little video we'll show.
Hidden below me is a different world, a whole ecosystem made up of intricately connected organisms, which make up the soil food web. This web is a complex community of organisms, each with its own niche, but all playing a vital role in the recycling of energy, carbon, and nutrients. In this 1 teaspoon of soil, there are over 1,000 million bacteria from 40,000 species, 20,000 species of fungi, and over 100 miles of fungal strands. This is an incredible amount of life.
So besides life in the soil, healthy topsoil has favorable chemistry, low in salts and sodium, balanced pH, adequate organic matter, and appropriate nutrients. It also has porosity. It's very important to have voids for air and water penetration and not be overcompacted to allow the plants and the roots to grow. Also, we want that healthy topsoil to be free of noxious weeds and invasive species. So if you do have healthy topsoil on a site, and the guidance will instruct on how to find out if you do have healthy topsoil on the site, you have a precious, irreplaceable resource to take care of and to utilize. It takes hundreds of years for nature to form just 1 inch of topsoil, and through our activities, just moments to discard or to waste or to destroy. And so that's why we need a topsoil management guidance document, and Holly is going to explain the layout of that document.
Thanks, Jim. So now that we know why topsoil is so valuable, we'll get back to this new topsoil management guidance document that is available on Mile High Flood District's website. You can just search for topsoil, and I think it's the third thing that comes up right now. I'm just going to go through kind of what's in the topsoil guidance and what you can expect. It's separated into 3 sections. Assessment, which is really pre-design. Then the design portion, which what do you need to do to plan for good topsoil management during construction? What do you need to do in design? And then what the things that you need to do in construction to ensure good topsoil management on your construction site. So the assessment phase goes through a desktop analysis and talks about the kind of information that you can get out of the NRCS soil survey, which is sometimes where an investigation stops for a project, right? But what we found is that this NRCS soil survey really needs to be verified before you get into construction, but it is a good start. There's also additional soil reports that you might have for the site. And then you can do an investigation into prior land use, which will inform you on additional information, such as, if the site has past agricultural use, you can expect high salt content in the soil. And this screenshot is just from the CDP, one of the maps that you can search on CDPHE's site of brownfields and other facilities that you want to note before you get to the site and take soil samples, which is also part of the assessment phase. So how do you collect soil samples? And how do you bag them? And which ones do you take to the lab for analysis? How many soil samples do you need? There's good information on all of these things in the guidance document. And then Jim showed you the soil triangle and talked about wanting to be not too sandy and not have too much clay in it, but somewhere more in the middle, and have a texture that's loamy. And so when you send these samples to the lab, what do you test for? That list is included in the guidance document and covers both texture, so where is it in the soil triangle, and also nutrients. And then how do you interpret those results? So you see on this, and this is just half of the table that I'm showing, you see that topsoil, we provide a spectrum from unsuitable to ideal. And so you will most likely get back from the lab that certain aspects of the soil fall in different categories. And you might have some that are ideal or suitable or marginal. But there are some characteristics that if they're unsuitable, you really should plan on importing topsoil. Marginal characteristics, and this is where maybe you're working with a vegetation specialist and they're helping you identify where you need amendments. But in the marginal category, that's where you want to look at some amendments. And it's to some extent just a matter of what you're trying to do and what vegetation you are trying to establish. But this will give you a better idea of what you have within your topsoil. And that's just a continuation of the table that includes pH and nutrients. And then the design phase really lays out how to put together a detailed topsoil plan. So some areas of your site, it's more critical to have good topsoil. Maybe you're doing something different with vegetation. Maybe you're in that site, you're just identifying areas where you need to place topsoil, how the depth of the topsoil, and you might have different qualities of topsoil within your site and want to use certain topsoil in various areas. And then it also goes through stripping, replacement, and specifications for topsoil handling, amendments, and other guidance. And then in construction, the construction phase outlines, when you want to have meetings, pre-bid meeting, pre-construction meeting, and what you can put on that agenda to make sure that you're covering what you need to talk about, specific needs for the project, and then absolutely just review with the contractor and communicate the work that's gone into the topsoil management plan so that there's a clear understanding of what needs to happen with topsoil. Topsoil management plans are not something that have been typical, on flood district projects to this point. And so this may be something new for the contractor, and it just speaks to the importance of good communication with the contractor. And then observation. When should you be observing the site? How frequently with regard to topsoil management? And then at what points do you want to be on the site? So that is a summary of what's in the guidance document. And I will turn it back over to Muller, and Sarah Johnson is going to go through some case studies.
All right, thanks, Holly. We'll start off with a couple of examples on how we use the guidance, and also examples on what was used to develop the guidance. One of those examples is the Lemon Gulch topsoil plan, and you can see from this picture that the channel is very sandy. It's got highly eroding banks and is very unstable. We did some 2D modeling on the channel to give you some background. And this is a design channel, and we worked to expand the conveyance as much as we could, but with the existing sand and even good vegetation, we weren't able to produce a very stable channel condition. So even with sandy soils and good vegetation, the channel would be highly erodible. So we modeled a condition where clay loam was introduced, and with clay loam and vegetation, we found it to be a better stable channel produced from the design. So we looked adjacent to the site, and there was a development site that had an excess of topsoil. So what we did is we did a desktop analysis following the guidance. We looked at the NRCS soil survey, which we can see here, and we can see we have a sandy loam and a clay loam right adjacent to the channel project. We looked at also other soil reports, and a geotechnical report was reviewed. We looked at the topsoil section, and what they had listed was topsoil, clay, sand, and organic. So really it could be anything, so it didn't give a lot of detail in what we were looking for. So next in the guidance, we did some soil sampling, and we developed a plan to sample the 2 locations that we identified, and then came up with a plan to perform soil sampling. We went out to the field and collected samples in plastic bags, and then we sent them on to the lab for analysis. What came back from the lab is here listed on the screen, and then we took this information and compared it against the guidance tables in the document. What we found is, looking at our percent sand, silt, and clay, is that we had a clay loam soil, which was very good for our stability of our channel banks. Next, we plotted this on the table provided in the document. So we find that we have a suitable texture with clay loam soil and 10% or less gravel that would pass a 2 millimeter sieve. So we are in the ideal category. Next, we looked at our salts, our organic matter, and soil pH, and we are all in the ideal category range. And next, we moved to the nutrient parameters, and we found that all except for one were in the ideal category. So then our amendments were specified. And overall, looking at the results from the Lemon Gulch site and the clay loam soil, we found that we were in the suitable and ideal categories for all of our parameters except for the nitrogen. Next, we wanted to design a topsoil plan that would make it easy to communicate to the contractor what we were looking for. And this topsoil plan was developed, and we'll go through the components here in the next few slides. We defined an area of topsoil stripping where we found the most ideal topsoil, and then also identified areas that we would like replaced with this topsoil. Also, a part of the project, the stream project was going to be constructed after the overlot grading, so we needed to stockpile some of the topsoil that was collected from the developer. So we identified that on the plan as well. Next, we identified areas and depths and also volumes that we were looking for each of the topsoil needs for the entire stream project, for what we would need replaced, and then what we would need stockpiled. And this was all communicated on one plan sheet. The next project we'll go through is Hess Ranch, and this is a more of an informal sampling that we used the guidance to see what type of soil was available on site. This is a large development in Parker, Colorado, and we are looking for soil to supplement detention pond and also swales. So we took samples in the field from an in-situ site that hadn't been disturbed, and you can see from the picture on the right that the soil is darker in color and maybe is even a little bit less sandy than you would expect from the channel that we saw earlier. We sent the samples to the lab, and then what came back was a soil that was mostly in the ideal range, except for some of the nutrient parameters that could be amended. So we are very excited to see this result. The next location on the site we sampled for was a topsoil stockpile, and this stockpile was quite large and it had a more sandy material, but we thought it might be in the range that we could use. So we took samples using a shovel and combined a few samples around the stockpile to have analyzed. The results of the analysis were pretty good. They were in the suitable and ideal range, as you can see, with some of the nutrients falling off. So our amendments would follow along with those recommendations. We haven't talked a whole lot about construction, but I wanted to show a few construction pictures from a project. Some of you may be familiar with the Chatfield Storage Reallocation Project, and one of the goals of the project was to provide mitigation of ecological habitat as a result of an increase in the water storage potential in the reservoir. So soils and vegetation was very important on this project. What I'm showing here is the subgrade being cross-ripped prior to topsoil placement. So not just ripping the topsoil, but also going down to the subgrade and ripping that as well to promote decompaction. This shows topsoil being spread over the subgrade on the site, and also topsoil being ripped prior to seeding and mulching. As you can see on the left-hand side of the picture, it looks pretty compacted, versus on the right side of the picture, it looks ripped compared to the left side of the picture, which is very good for seed germination and wouldn't allow loss of seed as much as you would see and promote infiltration and promote that deep root growth that we talked about earlier. The next is you can also check the compaction on the topsoil with a soil probe, and so that's just a picture of checking after it's been ripped on the site. And so with that, I'll conclude with a few points. Just to mention that soil and vegetation are very important. If you've heard anything in the talk, I hope you remember that. Not all topsoil is created equal, and the guidance has been developed to help identify what is located on your site and how to use the best topsoil for the best use. Good topsoil is a valuable resource. Conduct a thorough topsoil assessment and develop a thoughtful topsoil management plan. And use the best topsoil where it matters most, in those infiltration areas and those places where we want to establish vegetation. And good topsoil management should and can be applied in all areas of a watershed to protect water quality. And with that, I would like to thank you for your attendance and my co-presenters, along with Mike Sarmento from the Mile High Flood District, Jane Clary and Andrew Earls from Right Water, and Dave Buckner from ESCO and Associates for their collaboration on the project.